I am Hema Cholin, welcoming you to EPG Pathshala. Now I will be presenting on the topic Digital Preservation Part 2, wherein Part 1 module has been already discussed separately. Let us see some of the objectives to be discussed in this module. Digital preservation metadata, models and standards, major functions of preservation programs, and storage management of digital preservation, microfilming, a hybrid solution for digital preservation process, and major digital preservation programs initiatives in India and worldwide. Now let us see the introduction part. Preservation metadata is one of the vital building blocks in the digital preservation programs. Without preservation metadata, digital material will be lost. Preservation metadata provides the vital information which will make digital objects self-documenting across time. This part of the module provides an overview of preservation metadata, metadata models, standards and functions of digital preservation programs, and this module also discusses patterns of storage management and microfilming as a hybrid model being practiced for long-term preservation. The module outlines selected worldwide and Indian initiatives towards digital preservation programs. What is digital preservation metadata? It provides structured ways to describe and record information needed to manage the preservation of digital resources. It is one of the vital building blocks in the digital preservation programs and essential in order to establish and document the authenticity, integrity, provenance and trustworthiness of digital objects. Effective digital preservation depends on a set of preservation services such as conserving materials, digitizing collections, preserving library content in the digital formats, and providing robust education and outreach programs that needs digital preservation metadata to work together to ensure that digital objects are preserved for long term. Three types of digital preservation metadata are the OAIS model, that is Open Archival Information System. This OAIS reference model was developed by NASA's Consultative Committee for Space Data Systems as the conceptual framework describing the archival systems for the long-term preservation of digital data. This OAIS has been now been adopted as an ISO standard. The model establishes the terminology and concepts relevant to digital archiving and processes and information. A model consists of the three components for digital objects and their associated metadata. So, Open Archival Information System has three metadata, that is submission information package, that SIP is the content and associated metadata ingested into the repository at the time of deposit, and archival information package AIP is the content and associated metadata actually stored and managed by the repository over the long term, and dissemination information package, that is GIP, is the content and associated metadata provided by the repository in response to access request by the users. The metadata in OAIS model plays an essential role in preserving digital content and supporting its use over the long time. The OAIS information model implicitly establishes the link between metadata and digital preservation, that is preservation metadata. The OAIS reference model provides a high-level overview of the types of information needed to support digital preservation that can broadly be grouped under description information and representation and descriptive information. Let's see about preservation description information. The preservation description information consists of four major types of metadata elements. First is reference information, which is used for identification or description and includes global identifiers local to the archive, and some method of pointing to an existing descriptive metadata record for the resource such that it can be referred to unambiguously both internally and externally to the archive. For example, ISBN and URN. Next is the provenance information. It documents the history of the content information, example, its origins, chain of custody, preservation actions, effects and rights management, and helps to support claims of authenticity. So now let us discuss about the PREMIS, preservation metadata, that is implementation strategies. In 2003, OCLC and RLG established preservation metadata, that is implementation strategies, PREMIS, an international working group composed of more than 30 international experts in preservation metadata. PREMIS sought to define a core set of implementable, broadly applicable preservation metadata elements supported by a data dictionary, and identify and evaluate alternative strategies for encoding, storing, managing and exchanging preservation metadata in digital archiving systems. In September 2004, PREMIS released a survey report describing current practice and emerging trends associated with the management and use of preservation metadata to support repository functions and policies. The final report of the PREMIS working group was released in May 2005. The PREMIS data dictionary is a comprehensive practical resource for implementing preservation metadata in digital archiving systems. It defines implementable core preservation metadata along with guidelines and recommendations for management and use. PREMIS also developed a set of XML schema to support use of the data dictionary by institutions managing and exchanging PREMIS conformant preservation metadata. Each entity is described by a set of properties called semantic units. Each semantic unit represents a discrete piece of information to be recorded as part of the metadata supporting the digital preservation process. In short, a PREMIS semantic unit can be recorded in any way a repository finds convenient, given the processes and architecture of its repository system as well as its metadata management procedures. A semantic unit can be recorded as a single metadata element or broken up over multiple metadata elements if the repository prefers. METS, a standard for packaging metadata and content together in digital repository system. METS, that is metadata encoding and transmission standard, is designed to organize and link different types of metadata to its associated content in the OAIS reference model. METS is an XML schema designed specifically as an overall framework within which all the metadata associated with a digital object can be stored. These four sections are linked to each other by means of identifiers. The practical implementation of the METS can be very flexible as well. Any system capable of handling XML documents can be used to create, store and deliver METS based metadata, and METS provides the ability to associate a digital object with behaviors or services. Now let us see some of the major functions of preservation programs. The UNESCO's guidelines for the preservation of digital heritage describes the following functions that a full-fledged digital preservation program should perform. The creation of a safe place, that is, preservation programs must identify or create a safe place for storing and managing digital materials. Organizations may either set up its own infrastructure or outsource its digital preservation activity to a reliable third party. However, it is the responsibility of the concerned organization to ensure long-term availability of their digital contents. The process of loading a digital file into a digital repository along with its descriptive metadata for subsequent retrieval is referred to as an ingest. The steps involved in ingest include applying collection policies and selection criteria to ascertain whether material can be accepted on submission or not, checking the quality of the material submitted, including its completeness, authenticity, and ascertain that the material has duly been scanned for viruses, and also assigning unique identifiers to digital objects, assigning and managing copyright of digital material, assessing the elements that must be maintained, and assigning preservation objectives, setting retention and review periods for the digital material as deemed appropriate, checking and upgrading the documentation that describes the material including the technical and preservation metadata, checking the file formats and converting them into another format if so desired to comply with the policy of digital preservation program, and also saving digital objects and associated metadata after verification to the archival storage system. Now let us see about the archival storage. A digital preservation program should provide archival storage that maintains, protects and verifies the integrity of the stored digital objects and associated metadata, whether stored as a single data stream or as separate but linked data streams. The archival storage system must include practices to ensure protection of data stream from unintended change, damage or loss which can be achieved by regular copying of the data stream to fresh media or to new media types when necessary. Storage practices should also include regular checks such as checking of data stream against corruption, then system security, backup regimes that place copies at remote sites, and disaster recovery plans that address contingencies such as complete loss of the system's operating infrastructure. Let us see about the preservation planning now. The basic function of preservation planning is to monitor threats to accessibility to digital material and to specify action required to counter such threats. While archival storage offers data protection, its continuing access has to be ensured. The technology changes that affect accessibility should be monitored. The remedial action may involve migrating or upgrading of the digital objects into different format or encoding or changing the metadata that describes the means of access and links to current access tools. Now let us see about the implementing preservation strategy. Preservation strategies discussed earlier differ substantially in their method of preserving digital records. However, the process of implementation is quite similar. Steps involved in implementing preservation strategies adopted by the National Archives of Australia are that is identify materials required preservation, research appropriate preservation strategy, test proposed solution, backup records identified for preservation, apply the preservation treatment, audit the integrity of preserved records, destroy source records where appropriate, and establish monitoring regimes. Now let's see storage management for digital preservation. One of the crucial threats to digital preservation is short life of storage media, obsolete hardware and software, and slower read times of old media. The selection and installation of software components are crucial while building digital preservation program. The basic tenets of digital preservation extend much beyond storage media life. Devices used for reading storage media rapidly become obsolete. Various formats and the changing versions of digital documents and images introduce additional complications. The storage operation in digital archives primarily address to the media level formatting of information objects. Primary considerations for storage of digital materials include levels of hierarchy and redundancy. A digital archive may have multiple levels of storage depending upon the levels of expected use and expected retrieval performance. Digital repositories that are too large to store on a single disk can use hierarchical storage mechanism. In an HSM, the most frequently used data is kept on fast disk, while less frequently used data is kept in near line, such as an automated robotic tape library. An HSM can automatically migrate data from tape to disk and vice versa as required. Digital material in a distributed network may be stored online in multiple locations. Besides offline and online storage, nearline storage may be adopted, wherein information objects may be stored on optical or tape media and loaded in a jukebox. Retrieval time in nearline storage systems is higher in comparison to online storage, but is considerably more responsive to user demand than offline storage. A digital archive may use any or all of these methods. The most sophisticated systems combine the resources so that objects in use or recent use are stored online, and they age from the time of the most recent use. They move to near line storage and then eventually to offline storage. Redundancy is another important storage consideration. Effective storage management thus means providing for redundant copies of the archived objects to ensure availability of documents in case of loss. A number of array ID, that is redundant array of inexpensive disk models, are now available for greater security and performance. The RAID array ID technology distributes the data across a number of disks in a way that even if one or more disks fail, the system would still function while the failed component is replaced. Digital archives may also choose to make backup copies on their own or to make arrangements for other sites to serve as backup. Although hard disk, that is fixed and removable solutions, are increasingly available at an affordable cost. Optical storage devices including worm, CDR, then CD-ROM, DVD-ROM or optomagnetic devices in standalone or networked mode are attractive alternatives for long-term storage of digital information. Separation from the LAN, that is the storage system attached to a digital repository, should not only be accessible via devices physically connected to it or so that the storage system remains unaffected by traffic on the user LAN and vice versa. So that's all. To now let us summarize what we have discussed in part 2 of digital preservation. In this module, we discussed about various metadata specifications like PREMIS or METS and have the status of de facto standards with well defined community processes for maintaining and updating digital assets for long term preservation, while the Open Archival Information System OAIS reference model defines a framework with a common vocabulary and provides a functional and information model for the preservation community. The METS schema provides a flexible mechanism for encoding descriptive, administrative and structural metadata for a digital library object and for expressing the complex links between these various forms of metadata. The major functions of a preservation programs governed by UNESCO's guidelines for the preservation of digital heritage, and how effective storage management is possible through media level formatting of information objects are well discussed in this module. Other selected digital preservation programs in India and also discussed worldwide and also discussed about the initiatives taken in India also. So that is all. Thank you.